Hello guys. So in this session of stoichiometry, we are dealing with volume strength of hydrogen peroxide. Hydrogen peroxide, the concentration of hydrogen peroxide can be expressed in various ways. One of the ways is volume strength, normality and percentage concentration. Now why volume strength and what do you mean by volume strength? Let us consider hydrogen peroxide. Whenever we consider hydrogen peroxide and it always undergo decomposition. Decomposition of hydrogen peroxide gives you H2O and oxygen. So 2 moles of hydrogen peroxide gives you 1 moles of oxygen. Rather, we can say this way, 1 volume strength of H2O2 gives you 1 volume of oxygen. So, if I consider 1 liter of H2O2, it gives you 1 liter of oxygen at STP. If I consider 1 ml of H2O2, it gives you 1 ml of oxygen at STP. In that case, the volume strength of hydrogen peroxide is considered as 1. So, 10 volume H2O2. So, what do you mean by 10 volume H2O2? 10 ml of oxygen is liberated from 10 ml of H2O2. This way. Volume strength plays a very important role because in medicine, the H2O2 concentration is measured in terms of volume strength. So, how much oxygen is liberated, because that oxygen is used as a disinfectant. So, let us consider this calculation part first, then we will go for some problems. So, if we consider this calculation, it suggests that 68 grams of H2O2. So, molar mass of H2O2 is 34. So, 2 moles, so 68 grams of H2O2 liberates 1 mole, that is what, 22.4 liters at STP. So, if let us consider X is the volume strength, means X liter of oxygen is liberated. So, X liter at STP was liberated from what is the weight of H2O2. So, let us consider that is Y gram. So, Y is equal to 68x divided by 22.4, which means this become, we can say that, yes, if we calculate it further, if you go on calculating, it becomes 17x divided by 5.6 grams of H2O2. So, we are getting now what? Mass of H2O2, weight of H2O2. What we have to proceed? As we are determining mass, from mass we can go for percentage as well as we can go for normal strength also. So, calculation of normal strength of H2O2. So, what do you mean by normality? So, normality of hydrogen peroxide is equal to number of gram equivalents of H2O2 divided by volume of solution in liters. So, every time I will be using this term, volume of solution in liters. So, if the volume is not in liters, I have to convert it into liters. If it is given in a milliliter, then we have to multiply it by 10 raised to minus 3, this way. So, normality of H2O2 Therefore, I can write number of gram equivalent stand for weight of hydrogen peroxide divided by equivalent weight of hydrogen peroxide. Therefore, volume of solution in liters. So, normality of hydrogen peroxide is equal to weight of H2O2. This we have already got from this equation. So, 17x divided by 5.6 divided by equivalent weight of hydrogen peroxide, and that is 17, because molar mass of H2O2 is 34 and number of replaceable hydrogen ions are 2. So, 34 divided by valence factor, that is 2. So, 34 divided by 2 becomes 17. 17 multiplied by volume of solution in liter. So, normality of H2O2 is equal to the 17 get cancelled. If we consider volume of solution is 1, then x divided by 5.6. Here we will write if volume of solution in liter is equal to 1. So, 1 liter of solution I am considering now. Therefore, volume strength is equal to normality of hydrogen peroxide multiplied by 5.6. This is a very important relation we got. How? So, let us consider example. Example 1. If volume strength of hydrogen peroxide is 10, then what is the concentration of hydrogen peroxide in terms of normality? Okay, in terms of normality. So, it is possible to calculate directly because we have already derived all this thing. So, in books, if you observe that every time they have done this calculation part, but now we have this good relation. Volume strength is equal to normality of H2O2 into 5.6, right? So, we can directly use that relation. So, normality of H2O2 is equal to volume strength 10 divided by 5.6. If I consider this is approximately 6, so that approximately the answer is coming 1.9 something. So, the normality is approximately 1.9. Now, how can I calculate the percentage strength? To calculate percentage strength, we need to consider this again. Weight of H2O2 divided by volume, 1000. If we consider 1 liter multiplied by 100. So, here the volume strength, percentage strength which we are getting, that is W by V concept. That is by W by V. So, let us consider percentage strength concept. So, if I consider percentage strength of H2O2, so always remember that here the percentage strength is W by V. It is W by V. So, what is the percentage strength? Percentage strength is equal to weight of H2O2 divided by total volume of solution multiplied by 100. Obviously, that volume of solution I am taking in milliliters now. So, weight of solution we have 17x divided by 5.6 multiplied by 100 and whole is divided by 1000. So, if that cancelled, so we have now what? 17x divided by 56. So, even if we know volume strength, we can calculate percentage strength. So, we will solve one more problem based on the volume strength, rather the expression of hydrogen peroxide in next session. Thank you very much.